My dear students, today we will discuss about the problems related to the properties of the system. So far, we have discussed the so many properties of the system. That is linearity property, causality property, time invariant property, static and dynamic property. We have discussed so many properties of the system. Today we'll solve some problems and we'll come to know whether a particular system is stable or not, causal or not, linear or non-linear, time invariant or time invariant. All that we'll discuss. Today with an example we'll come to know, we'll find out what the will find out whether the system is fulfill all the following properties. Okay, with an example we will discuss. For example, determine whether the following continuous time systems. Here these are all problems are related to continuous time systems. Continuous time systems are static or dynamic, linear or non-linear, shift variant or shift invariant, causal or non-causal, stable or unstable. We have to find out whether these systems are obeys the following property. For example, first we will see one the equation. That is equation is y of t equal to 10x of t plus 5. This is the equation of a system. For a particular input of x of t, it will produces output y of t. This is the equation of a system. Now, from this equation, we'll come to know whether the system is stable or unstable, causal or non-causal, whether it is static or dynamic. We'll come to know. We'll discuss all that one using this equation, and we'll analyze the properties of the system. For example, first we'll take the first problem. That is y of t equal to 10x of t plus 5. This is the equation of a system. Then from this equation we'll come to know whether this system is one by one we'll discuss about the properties of the system. From this equation we'll come to know that first is what here output depends upon the present input only. The output, that is y of t, depends only on the present input. Therefore this system is a memoryless, or we call it as a static system. If this output y of t depends, not only depends on the present input, so it also depends on the past input, then such systems are called as dynamic systems. But here it is not like that. It is only depending on the present input, that is x of t. Therefore this system is memoryless or static system. Already we discussed so many properties of the system. There we have discussed about whether the system is static or dynamic. There we have discussed all about these concepts, whether the static or dynamic, all that we have discussed. Therefore, since it is depending on the present input, this system is memoryless or static system. First property. Second property will discuss, will find out, will analyze whether the system is linear or non-linear. Take this, that's the same system, that y of t equal to 10x of t plus 5. Here in this what we'll do, we will consider that as first, that is we will apply the same equation and we will find out y1t, that is function of x of t is there, no, that we will consider as x1t, function of output is function of input x1t, that is equal to we will write that is 10x1 of 10x1 of t plus 5. Similarly we will find out y2 equal to function, it is also what is output, what is function of output, it is depending on the input, that is 10x of t plus 5. Therefore here for same equation we will find out y2t, will y2t is equal to function of x to t, that is nothing but 10x to t plus 5. Therefore, first, now what we'll do, we will use this equation. What is this? y3 of t equal to a1 y1 t plus a2 y2 of t. This is the equation. First, this is we call as y3, that is y3 of t. Here suppose we want to find out the linearity property, then the system will be linear. Suppose if it is linear, that is if it is for continuous time system, y3 dash of t equal to f of function of a1 x1 t plus a2 x2 t. Then and y3t will take it as a1 y1 t plus a2 y2 t. This is for continuous. For discrete, y3 dash n equal to function of a1 x1 n plus a2 x2 of n, and this is y3 dash n for this is for discrete system. This is y3 dash y3 n equal to a1 y1 of n plus a2 y2 of n. Then this is what, this is y3. The above is what, y3. That is y3 dash t, if it is equal to that is y3t, that is here you see this one, y3t is equal to y3 dash t, then that system we call as linear system. This is y3t means these systems are continuous system. Similarly, if y3n equal to y3 dash n, then this system is we call as a linear system. Suppose if y3 of t is not equal to y3 dash of t, then such system we call as non-linear system. This is important. First, we'll for the same equation we'll find out what is y1. That is here we'll find out what is what is that y1. For same equation apply y1, we'll find out y2 and you use this equation. First what we'll do, we'll find out what y3 of t, that is equal to a1 y1 plus a2 y2. In place of y1 and y2 we put these values, that is y1 t equal to 10x1 t plus 5. For y2 t we'll place as 10x2 t 5. Therefore, here in the equation y3 t equal to a1 y1 t plus a2 y2 t. Therefore, it is equal to a1. In place of y1, what will write? Y1 equal to 10x1 t plus 5. Then plus what? Plus a2 y2 plus a2 y2. Y2 is what? 10x2 x2 t plus 5. Then elaborate this equation. When elaborate this equation, then it will be 10 x1 of t, 10 a1 x1 of t plus here a1 is common. Therefore, we multiply this a1 to 5 also. Therefore, it becomes 5a1. Then plus here a2 is common. A2 we have to multiply to 10x2 t plus 5. Therefore, this will be that is 10 x2 a2 x2 of t plus 5 a2. This is what, this is your y3t. Now we'll find out y3 dash t, that is y3 dash t equal to response of linear combination of input becomes y3 dash. That is for calculate y3 dash t, this is the equation. That is y3 dash t is the function of f of a1 x1 t plus a2 x2 t. Therefore, here only we have to take about the input. Therefore, 10 a1 is constant, will place as it is, x1 t as it is, plus a2, this x1 and x2 are the inputs. Therefore, we have in place of x1 we have to place, and other things, this constants and these values we have to place as it is. Then when we multiply this 10 to this equation, complete equation, then it will be 10 a1 x1 t plus 10 a2 x2 t plus 5. This is what, this is your y3 dash t. Therefore, here you see here this expression 10a1 x1t plus 10a2 x2t plus 1. This is what y3 dash t. But here you see this is what your y3t is what 10ax1t plus 5a1 plus 10a1 to x2t plus 5a2. This is your y3t. But therefore, but it is here it is different. It is different. You see here this equation, that equation, both are different. Therefore, this here y3 dash y3t is not equal to y3 dash t. Hence this system is not linear system, or this we call as non-linear system. You refer the notes, you will refer the notes, that then only will come to know the what are the how we'll calculate the various properties of the system. Here you have to take the notes, important. So many problems I solved, nearly 10 problems related to find out whether the system is stable or not, causal or not, whether it is linear, non-linear, everything is there. Therefore I already told that you have to purchase xerox of printout of or xerox of these notes which are given in the xerox center. Please collect it, refer it, so that in that notes I have here I may discuss one or two problems, but in the notes I have solved more than 10 problems related to this properties of a continuous time system. Then for discrete it is also different. For discrete also I have discussed nearly 8 to 10 problems related to discrete time systems. That is whether the discrete time system is causal or not, whether the system is stable or unstable, whether it is linear or non-linear. Those also I have solved in the notes. Therefore I request you to I request you to take the xerox or printout of these notes which I have given already in the WhatsApp group. I have messaged about this information. Okay, next is what whether you will find out whether the system is causal or time invariant or not. Therefore, response to the delayed input becomes if will response the input, that we call as t1 equal to f of x t minus t1. Therefore that we place x of t as we place as instead of x of t we'll write as x of t minus t1. Rest of the thing as it is, then xt minus t1 plus 5. Now what we'll do, let us delay the output itself. For this replace t by t minus 1. That is why here it is y t1. Suppose we replace output itself, let us delay the output itself. Then it is what it is, y of t minus t1 equal to 10 x. In place of t you write t minus t1. Here also in the equation, what is that? 10 x of t is there. Here in this equation 10 of x of t is there. That will replace by what? T minus t1. Therefore it will be 10x t minus t1 plus 5. Therefore here you see, if you delayed the input, we got the output as 10x of t minus t1 plus 5. When we delay output itself, that means we replace t by the t minus t1, then we will get this equation. That is what y of t minus t1 equal to 10x of t minus t1 plus 5. Here you observe that one, y of t comma t1 and y of t minus t1 both are same. Here y of t comma t1 is equal to y of t minus t1. Hence the system is time invariant. Time invariant means as there is shift in the input, corresponding if there is shift in the output, then such systems we call as time invariant systems, and the system is time invariant. That is about how we can find out whether the system is time invariant or not. Then fourth property is what? Since the output depends on the present input, it is causal system. Which system we call as causal system? If the output depends on the present or past inputs, then the system is causal. If when we call the system is non-causal, if the output depends on the future inputs, In real application, in real world, such systems are not there. If it is there, then that systems we call as a non-causal system, since the output depends upon the present input. Therefore this system we call as causal system. Then fifth one is that is yt is bonded as long as xt is bonded. Hence this is stable system. Thus, the above system, that is what y of t equal to 10x of t plus 5 is what it obeys. It is the properties of this system is that thus this system is memoryless or static, and it is non-linear. Why it is non-linear? Thus the y3 of t is not equal to y3 dash t. Therefore this system is non-linear, time invariant, and causal stable. This is how we have to find out the various properties of the system. That is about some properties of the, how we can find out the various, we can determine the various properties of a system. That is here in exam also they will ask, they will give a particular equation. There are so many equations, so many problems are there. For your understanding purpose, I am discussing only one problem here. That is, if you any take, that is you take, then apply these rules, so that you will find out whether the system is linear, non-linear, shift invariant or variant, or it is causal or non-causal, whether it is stable or unstable. Like, you'll find out the various properties of the system. Okay. In the next video lecture, I will discuss one more problem related to the finding the properties of system related to discrete time system. It is about the finding the properties of the system of the system which are continuous time systems. These are continuous time system, but for discrete time systems, we will discuss with I will make another video lecture. From that, we will come to know how we can find out the various properties of a particular system. Okay, okay. Thank you.